Let us continue looking at measurements. This time we're going to look at area. Previously we looked at lengths, and we saw that length, when it comes to measuring lengths, you have certain standard units of measurement in which you can tell somebody, or somebody can tell you, how many of those units are between one place and the other, and you immediately know what they're talking about. All right, and you have the inches, feet, yards, miles. You also have millimeters, centimeters, meters, kilometers. Now let's look at area. When you're talking about an area, one way I would put it is that area is the size of a surface. For example, the floor of a building, right? The larger the room in terms of how far the walls are from each other, the greater the area. You can have the area of a lawn. A bigger lawn has a bigger area. Smaller lawn has a smaller area. Now, when you talk about 1 centimeter, a distance of 1 centimeter will be, say, from here to here. That's 1 centimeter. All right, it could be from 3 to 4. That's 1 centimeter. But suppose you do this. Let us say from 5 to 6, you have a distance of 1 centimeter. You take another line. This is also 1 centimeter long. This other line on this side, 1 centimeter long. You're placing them at 90 degrees to each other, and you close this shape with a 4th line, also 1 centimeter long. What you have is a square. You have 4 sides. You have each corner at right angles to each other. All right, so this shape is called a square. A quadrilateral, that means 4 sides where each internal angle is a right angle. And you remember, when we talk about the internal angles, we're talking about, where's my pencil? The angle right in here. All right, right in here. Nice, that angle. All right, if you're not yet familiar with angles, we'll talk about that at a later time. Now, this is 1 centimeter square. Why do you call it centimeter square? That's because if you want to find out the size of the area that this covers, what you have is 1 centimeter. Let me find back my letters. Right, so at this point you have 1 centimeter. This is 1 centimeter high, and then at this point you also have 1 centimeter. That's 1 centimeter wide. Now to find the area, you say 1 centimeter multiplied by 1 centimeter, and that gives you 1 centimeter squared. 1 square centimeter. All right. Now, you might have a case where you want another square centimeter. Let me erase these first. And you want another square centimeter. What you can do is this. Let me just copy this and paste it. It normally comes up here. I make a copy of this. Alright? Okay. I make a copy of this and put it here. Now I have 2 centimeter squared. 2 squares here. 2 square centimeters. Right? Let me just redo this part. So I have 2 centimeters squared. Notice the height is 1 centimeter, the width is 2 centimeters. So I have 1 height by 2 wide. We have centimeter multiplied by centimeters, and we say that is centimeters squared. Just like when you have 5 multiplied by 5, what you have is 25, which is 5 squared. We call it squared. So the height 1 centimeter multiplied by the width 1 centimeter gives you 1 centimeter squared. Now in this case, the height 1 centimeter multiplied by the width 2 centimeters for both will give you 1 by 2, which is 2 centimeters squared, or 2 square centimeters, however you want to call it. Now let me paste again, and I have my square here. Let me just copy this one, copy. I'm going to paste it later on. Let me move this right here. I want to put it here. What do I have? It's 3 square centimeters. Then I also have this. And this makes a total of 4 square centimeters. I have 1, 2, 3, 4. 4 of them. 4 squares. And each of them is a centimeter. So what I have here is a height of 2 centimeters and a width of 2 centimeters. So this gives me 2 multiplied by 2, or 2 centimeters multiplied by 2 centimeters, and that gives me a result equal to 4 centimeters squared. You would normally write the square as a superscript, but I don't have that feature in this software, so I just put the 2 here. Now you can write CM2, that's the short way. I'm going to write squared centimeters, although my figure is running off the screen. So what I have here is a total of 4 square centimeters. Alright? 1, 2, 3, 4. In other words, 2 high. That's 2 high by 2 wide. 2 centimeters high by 2 centimeters wide. 2 multiplied by 2. That gives me 4 centimeters squared. So the 4 centimeter squares are 1, 2, 3, 4. You see that? So that is the area of this shape which I have. 4 centimeters squared. Now I could very well put 2 additional ones here, 2 additional shapes right here. Alright, suppose I do this, one more here and another one here. let me just erase this edge. Alright, let me fill in these little spaces here. What I really have is 6 square centimeters. That's 1, 2, 3, 4, 5, 6 square centimeters. 6 of them. Now notice this height here is 2, and this width here is 3. 2 high times 2 wide. Instead of counting 1, 2, 3, 4, 5, 6, when I see this, I could just say how high is it, how many units high is it, or how many units wide it is, and say 2 multiplied by 3. This will 6 centimeters square. So changing these figures now, I'm going to have a height of 2 centimeters, 2 cm. Let me move my 2 cm over here, because this is 2 centimeters high, 1, 2, and then I have 3 centimeters wide, 3 cm. Now here is 2 multiplied by 3. So the area of all of this shape is 2 cm multiplied by 3 cm. I use the asterisk for the multiplication sign. I don't have the multiplication sign here. 2 by 3 gives me 6 cm squared. Again, this 2 would normally be a superscript. Alright, but since I don't have a superscript here, I could say cm squared, centimeters squared, or I could rewrite it as square centimeters. So what I have here is the area. This area is 2 centimeters multiplied by 3 centimeters is equal to 6 square centimeters. Okay, good. Now, in this case, what I have is not a square, it's a rectangle, because the width and the height are different. Alright? The width and height are different, so it's not a square. You do have formulas for calculating the areas of other shapes in which you don't have definite squares. For example, the triangle, which we're going to look at later. You have the trapezium, the circle. We're going to be dealing with those at a later time. Here, let us, before we finish, talk about other units of measurement. You can have the square inch. It follows similar principle as talking about the square centimeters, but instead of having 1 centimeter by 1 centimeter, and you see how many of those are in the area, what you do is talk about each square being 1 inch by 1 inch. Now, you also have the square feet. Some painters, they charge by how much money they charge by the square feet. They charge you a certain amount of money per square foot to paint your house. When you have persons who are splashing or dressing a wall, those of you in construction would know about this, then the common practice nowadays is to charge a certain amount of money per square yard. That is, on the wall, if you have a height of 1 yard by a width of 1 yard, they charge, for example, $300 to cover that 1 yard. So they might charge $300. I'm talking about Jamaican dollars here, to rough cast or dress a square yard of wall. You have persons who do tiling. Many of them charge by the yard. Some persons might charge by the square meter instead of the square yard. But it's common nowadays to use the square yard to charge you a certain amount of money per square yard of tiling. Now, when you're dealing with purchasing land, you do have the square yard. No, it's not that common to use the square yard. The most common areas, the units of area for land, are the square feet, right? You have the square feet. You might say square foot, but once you move to more than one, that's square feet. They might charge per square meter, METRE for Britain, METER for Americans. Another area, unit of area that they use is the acre. You might have a quarter acre of land, half acre, 1 acre, and so on and so forth. 1 acre is a little more than 40,000 square feet. So a half acre is about, it's more than 20,000 square feet. Alright? But you can look up these figures, the exact figures, if you really want to do that. But you do have some unit converters which you can download and install and convert from one unit of area to another. Not just area, but lengths and other units as well. Now, these are commonly used units of measuring area. So area is really, in my words, the amount of surface, whether on a land or a wall or a floor of a building, whatever it is, how much surface, the magnitude of that surface. You can calculate it when you have a rectangular shape by the length multiplied by the width. Common units are the centimeter square, square inch, square meter, square yard, and the acre for larger areas. That's when you're dealing with real estate or land transactions. You use the acre. All right. Now, at a later time, we'll go into calculating, actual calculations dealing with areas. But as I said, we're not going to go too much more into this video. In fact, we'll end at this time. So I will see you in the next video.